Hey everyone, in this video we will have a look at congruent quadrilaterals. In the previous video we had a look at congruent triangles, and we will use those ideas to prove certain elements of quadrilaterals. A quadrilateral is a four-sided enclosed shape whose interior angles sum to 360 degrees. It's really important that we know that. So over here we have quadrilaterals. So any shape with four sides that's enclosed is a quadrilateral. Then we have three sub-branches. The first is a kite. Then we have trapeziums. Then we have parallelograms. Parallelograms also form two subgroups called rhombus and rectangle, which then have the mutual subgroup of squares. We'll have a look at most of these in a bit more depth. A trapezium is a quadrilateral with one pair of opposite sides that are parallel. So over here, one pair of opposite sides that are parallel. But they are not necessarily equal length, okay? So they're parallel, but they're not equal length. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So it's not only one, it's both. So we have one pair over here, and then we have another pair over here. Therefore, opposite angles are equal, opposite sides are equal, and diagonals bisect each other. A rhombus is a parallelogram, but all four sides are equal. So a diagonal, so it has the same properties as a parallelogram. In addition, diagonals bisect each other at a right angle, and diagonals bisect the angles at the vertex through which they pass. That was a rhombus. A rectangle is a parallelogram whose interior angles are right angles. So these angles over here are all right angles. So their diagonals are equal, diagonals bisect each other, and all angles are right angles, which means they're equal to 90 degrees. And a square is a shape, a parallelogram, with the interior angles that are right angles, and all four sides are equal. So all angles are right angles, all sides are equal. The diagonals are equal to the length and bisect each other at a right angle, and diagonals bisect the vertex through which they pass at 45 degrees. So these are the properties of quadrilaterals. We will use these qualities as well as what we learnt in congruent triangles to prove that a parallelogram with opposite sides that are parallel has equal opposite angles. So let's get started. First thing first, I'm going to label this angle over here X to start off with. What I want to do is I want to prove that opposite angles are equal. So this angle over here is the same as this angle over here. So I have therefore sliced my quadrilateral into two triangles. I have formed the line BD, and I have two triangles, so triangle 1 and triangle 2. I've labelled this angle over here X. Now to start off with, X equals, this sign means angle, and X is between CDB. CDB. Now, we can say that that is the same as this angle over here using the alternate angle rule. So let's write that down. That's this angle over here is therefore X. So that is ABD. We could use the same idea. I'm just going to label this angle over here F. Use the same idea that we just used to prove that x is the same for both triangles to show that these f's are also the same. So I have ADB, and that is the same. So this over here, F is the same as this F over here using the alternate angle rules. Again, so that's C, B, D. And over here I'm just going to write since alternate angle. Remember, alternate angle was when we have a Z. These interior angles are the same. That's what alternate angles are. All right. So we've proved that the angles are the same since angle D is x plus f, and angle B, well, I shouldn't really write it that way, AB, so ADC, this one over here, the whole thing is the same as this whole thing, which is going to be ABC, which is x plus f. So we could conclude that the angle ADC is the same as the angle ABC. Second step, we know that both the triangles share the line B and D. Let's write that down. I'll just do that. So since both triangles share BD, it's the side, we could conclude that the triangle ABD is congruent to the triangle CDB because we have two angles. It's angle 1, angle 2, and a side. And given the side is between the two angles, we can conclude that these two triangles are congruent using the angle side angle rule. Since these two triangles over here are congruent, meaning that they're identical, then the opposite angles also have to be identical. So angle DAB is therefore equal to the angle BCD. So opposite angles are equal. So we have proved that a parallelogram has equal opposite angles.